Hello everyone, welcome back to my channel Data Carrot. Today we are going to look to solve a problem that you encounter every time you book a movie ticket or a flight ticket. How does the system find two or more empty seats that are sitting right next to each other? This is one of the most important and tricky SQL interview questions asked in data professionals interview. In the tech world, this is also known as a logical sequence problem. By the end of this session, you'll know not only how to solve this seed problem, but you'll also understand how to find patterns in any time series or sequential data, a skill that will separate beginners from experienced ones. Think about apps like Book My Show. When you choose two tickets, the app doesn't just show any two random free seats. It looks for neighbors. Our database represents this simply like when a seat is free, it is defined as 1, and when it is occupied it is defined as 0. Our mission is to write a query that identifies these islands of ones that are at least 2 units long. Let's look at the data we are working with. Here is our cinema table. It has two columns, seat ID and free. Seat ID column is our sequence. For this video we assume them as integers so we can use basic math to find the neighbors. Free column is the Boolean style flag. Looking at the rows, which seat should be in our final result? The answer is 3, 4, and 5, right? The first way to solve this problem is by using a self-join. Imagine you have two identical physical printouts of the same table. You lay them side by side on your desk. You want to see if table A has a free seat, then check if the immediate neighbor in the table B is also free. We aren't creating a new table in the database, we are just telling the SQL to treat the same table as two different entities, that is A and B. Let's look at the code line by line. This is the heart of our self-join. From cinema as A, join cinema as B. In this part of the code, we are joining the table to itself. A and B are the aliases, or also the nicknames that we have given to our table, so the SQL doesn't get confused. The part of the query where we use on absolute of a dot seat id minus b dot seat id is equal to 1 is the neighbor check. If we subtract seat number 3 from 4, the result is 1. The absolute value function ensures that when we do 3 minus 4, we get 1 instead of minus 1. This allows us to find a seat and its neighbor regardless of if it is on the left or the right. The part where a dot free is equal to 1 and b dot free is equal to 1 is our filter. We only care about pairs where both of the tables show seat is available. Also, select distinct of a dot seat id is very crucial. If seat number 4 has seat number 3 as a free neighbor and seat number 5 as a free neighbor, it will appear in our join results twice. The distinct makes sure that each seat id is only listed once in our final result. Now let's look at the modern and a more powerful way, that is using Windows function. In a self-join, we usually clone the table and it can be very slow. With Windows functions, each row stays in its place, but it gets a looking glass or a peek into the row up above it using the lag function and the rows below it using the lead function without it actually leaving its position. It is significantly faster on large data sets. This query uses a subquery, which is a query inside a query. Let's look at the inner query first. Lead of free over order by seat ID. This looks at all the free status of the next row. Lag of free over order by seat ID. This peaks at the status of the previous rows. Over order by seat ID. This is the window part. It tells the SQL when you look for the neighbor, make sure you are looking at the seats in a numerical order. For the outer query, once we have looked at the values of the previous and the next rows, we simply filter out the rows where the current seat is free and either it is previous or the next neighbor is also free. This covers the start, middle, and the end of any sequence. So which one should you use in real life scenarios? In self-joins, it is easier to visualize for beginners, but it's very expensive. If you have 10,000 seats, the database has to look and do a 10,000 into 10,000 row comparison. This is lot of compute resource wastage. Windows functions are very much optimized. The database scans the tables once, keeping the neighbor's value in memory as it moves down the list. It is the professional standard for performance. Now, working on a legacy databases, you will be forced to use self-joins as you cannot use Windows functions there. Else, most of the modern day applications will definitely use Windows functions. If you are doing a complex sequence analysis, Windows functions are much easier to read and maintain. If you get this question in the interview, don't directly start with your coding. You can ask the interviewer some follow-up questions like, are the seat IDs perfectly sequential? Are any of the seat numbers missing or duplicate for any reason? Because the seat minus one logic will break in this scenario. If that's the case, you can tell them that you'll start by using a row number to create your own ordered rows to first create clean a gapless sequence, and then you'll start with your logic. This shows you, the interviewer, that you actually think about the data quality and not just the syntax. With this, we come to an end. I hope you liked the video and found it useful. Please like, share, and subscribe, and also leave behind any of your questions in the comment section. Stay tuned for more such videos.